In this lesson, we will look at the cosine law and how it's used. We have used the primary trig ratios, sine, cosine, and tangent, to determine the side lengths and angle measures in right triangles. However, we can't use sine, cos, and tan in triangles that don't have a 90-degree angle. So for these triangles, in order to find the side length and the size of the angle, we can use the cosine law. So in order to use the cosine law, we have to make sure that our triangles are labeled properly. So our angles are labeled using a capital letter, our sides are labeled using a lowercase letter, and the corresponding angle and side are directly across from each other. So if we have angle A here, then side A is directly across from it. For angle B, side B is directly across from it. And for angle C, side C is directly across from it. So for the cosine law, we can use any one of these three cosine laws. They're all very similar. The only difference is which side has been isolated on the left-hand side. So notice that in each of them, the isolated side matches up with the angle that's used with the cosine. So we have the side A and angle A. For the second one, side B is isolated, and we're using angle B. For the third one, side C is isolated, and we're using angle C. Inside each of the cosine laws, notice that the sides that are used are the same. So here we're using side B and side C, and we're using it 2 times. Side A, side C, we've got A and C. Side A and side B, and we're using A and B. Okay, so the cosine law is like this. A squared equals B squared plus C squared minus 2BC times cos A. So let's do an example to show you how it works. In this example, we want to determine the indicated side length using the cosine law. So we're looking for side Q down at the bottom. So because we're looking for side Q, that is the side that's going to be isolated. So we'll have Q squared. Then we're going to have the other 2 sides that we already know are going to start the right-hand side of the equation. So Q squared equals S squared plus R squared minus 2SR times cosine of angle Q, because we know that and because we are looking for side Q. So now we're going to substitute in what we know. So we'll have Q squared equals, S is 3.2, so 3.2 squared. Side R is 3.1, so plus 3.1 squared. And then we're going to subtract 2 times side S of 3.2 times side R of 3.1 times cosine of angle Q, which is 66 degrees. In the next step, we are going to square each of those 2 pieces, and we're also going to multiply out those 4 terms together. So Q squared is going to equal 10.24. Then we're going to square 3.1, so 3.1 times 3.1 gives us 9.61. And then when we multiply out 2 times 3.2 times 3.1 times cosine of 66, we can multiply all 4 of those together, and we'll get 8.07. So the next part, we want to figure out what Q squared equals. So we'll add our 10.24 and our 9.61, and then we're going to subtract our 8.07. So we're going to add first, and then the second number we subtract. So when we do that, we'll get to 11.78. And then our very last step is just to square root both sides so that we figure out the value of Q, which is 3.43, and we're using meters, so 3.43 meters. For the next example, we want to determine the length of CB to the nearest meter. So we're looking for that line there. Okay, so this will be side A because it's directly across from angle A. Our 32 will be side B because it's directly across from angle B. And 40 will be our side C. So because we're looking for side A, we are going to start our cosine law with a squared. Then the other two sides get put after the equal sign. So a squared equals b squared plus c squared minus 2bc times cosine of angle A, because we know angle A and we've also started our cosine law with side A. So now substitute in what we know. So a squared is what we're looking for. Our b is 32, so we'll square 32. C is 40, we'll square 40, and then we'll multiply 2 times b, which is 32, times c, which is 40, times cosine of angle A, and angle A is 58 degrees. So our next step is to calculate. We'll square the two numbers, and then we'll multiply those four terms together. So a squared equals 1,024 plus 1,600 minus 1,356.6. So our 1,024 came from our 32 squared, so 32 times 32. 1,600 came from 40 squared, 40 times 40. And then we multiplied our four terms together to end up with 1356.6. So next step, we're going to first add 1024 plus 1,600, and then we're going to subtract the 1356.6. When we do that, we'll end up with 1267.4. And our last step, we want to square root both sides. So our A value will equal 36 meters. And it says up here to the nearest meter, which is why we didn't include a decimal. Morgan and Alyssa leave their school at the same time in different vehicles. They travel on straight roads that diverge by 70 degrees. Morgan travels an average speed of 45 kilometers per hour. Alyssa travels at an average speed of 55 kilometers per hour. How far apart will Morgan and Alyssa be after 45 minutes, which is the same as 0.75 hours, to the nearest tenth of a kilometer? So in this diagram that's drawn for us, our 70-degree angle here is where our school is. I'm going to label it with S. Okay, so let's say that Morgan is driving the yellow car, and we know that Morgan is traveling at a speed of 45 kilometers per hour. And let's say that Alyssa is driving the red car, and she is driving at a speed of 55 kilometers per hour. So now the question asks us how far apart they will be to the nearest kilometer. So we want to be working in distances, in kilometers, but right now all we have is the speeds. So in order to find the distance or how far apart they're going to be, we need to use the 45 minutes or the 0.75 hours, and we need to multiply it by the speed that they're going, so the 45 kilometers or the 55 kilometers. When we do that, that will give us how far they have gone. So if we take 45 kilometers per hour and we multiply it by 0.75 hours, we will end up with 33.75 kilometers. And that's what we're going to use for our cosine law. We have to do the same thing for the red car. So this person, Alyssa, is driving at 55 kilometers an hour. If we multiply that by how long she's been driving, so 0.75 or 0.75 hours, when we multiply that, we will get 41.25 kilometers. So we want to be using the distances that they're driving, not the speeds, because we're looking for the distance that they are apart. We're looking for this line here. Okay, so I'm going to label these with M for Morgan and A for Alyssa. So we're actually looking for side S. Side M is going to be the 41.25 kilometers, and side A is going to be the 33.75 kilometers. So for our cosine law, we're looking for S, so we'll start with S squared, and this will equal A squared plus M squared minus 2AM times the cosine of angle S. So now we're going to substitute in what we know. So our A value is 33.75. We're going to square that. Plus our M value is 41.25 squared. Then we're going to subtract 2 times our A value. And we're going to multiply that by our M value, 41.25, times cosine of angle S, so the cosine of 70 degrees. So now we're going to square the 33.75 to get 1139.06. We'll square the 41.25 to get 1701.56. And then we'll multiply these four terms together to get to 952.31. So now we're going to add our first two values together and then subtract that 952.31. When we do that, we'll end up with 1,888.31. And we'll square root both sides to get to 43.5 kilometers. Notice that the question said to the nearest tenth of a kilometer, which is why we have one decimal place in our answer. So the distance between the two vehicles, or between Morgan and Alyssa after 45 minutes of driving, is 43.5 kilometers.